buenas tardes. Os damos la bienvenida. Muy buenas tardes. Os damos la bienvenida a este último webinario del curso en Innovaciones en la detección, el diagnóstico y la atención temprana del autismo, que se alberga en el portal Orange Digital Center de la Fundación Orange. Hoy tenemos la suerte de contar con el doctor Herbert Roeyers. Buenas tardes, Herbert. Él es profesor de Psicología Clínica y jefe del Laboratorio de Investigación en Trastornos del Desarrollo de la Facultad de Psicología y Ciencias de la Educación de la Universidad de Gante, en Bélgica, y estudia muy a fondo los trastornos del neurodesarrollo, principalmente el trastorno del espectro del autismo y la discapacidad intelectual, así como el desarrollo atípico en niños nacidos a término y prematuros. Es autor de cientos de artículos científicos muy relevantes en el ámbito de la investigación y hoy nos va a hablar del diagnóstico precoz en el autismo, de las promesas y los desafíos actuales. Un tema muy interesante que va a completar muy bien los contenidos del curso porque nos va a ayudar a entender muchos de los estudios y sus resultados, que existen miles de estudios actualmente en el ámbito de la detección y el diagnóstico del autismo y cómo trasladarlos a la práctica clínica de manera que podamos adaptar nuestras estrategias y conseguir unos mejores resultados y tomar decisiones acertadas. Muchísimas gracias por acompañarnos, gracias también al profesor Ricardo Canal por ayudarnos en la programación de este webinario y bueno, gracias a todas las personas que asistís, también a Lupe Montero por su asistencia y a Sergio Baños por la interpretación que hace que este webinario sea posible también escucharlo en español. No te quito ni un minuto más, Herbert, cuando quieras podemos empezar. Gracias.
Okay, thank you very much for the introduction. Good evening. I'm sorry I cannot speak Spanish. I can do a few words, but you would not like to listen to that, so I'll do it in English. As you all know, we have now the fifth version text revision of DSM, and we also had previous versions, but in all the versions of DSM, it is clear that autism originates in early childhood, and also in DSM-5 text revision is mentioned that the symptoms must be present in the early developmental period. We also know from research that in contrast to other conditions, that autism is a categorical something. So there is strong support, as you can read, for the categorical structure of autism or autism spectrum disorder, as it is called in the DSM-5, with the category corresponding closely to clinical diagnosis. So while we tend to think that conditions or disorders or whatever we call them should be more viewed on a dimensional scale, this apparently is not the case for autism. So it means that we can identify autism and diagnose autism, and that there is a sort of border between autism and non-autism that should be fairly clear, as you also can see here in the figure. Now, if we look at research and if we look at overviews and meta-analysis, then we see that in this overview, which was published a few years ago, that in general, the age of diagnosis of autism worldwide is around 60 months of age, so 5 years. And if we only consider children younger than 10 years, it is still more than 40 months, which is not really what is meant by the very early childhood. In another paper that was published in 2015, where one of my colleagues, Petra Warijn, contributed to this paper, they looked at European data and more or less the same came out. It was On average, the diagnosis was at 42 months. There was no effect of educational level of the parents in that study, but children with better language skills, children who were able to speak in complex sentences, and especially girls, apparently are diagnosed later. Also in this study, there was an age limit. It only concerned children who received the diagnosis before they were 7. So it's biased, so the actual age of diagnosis will be higher. Now, why is the diagnosis of autism rather late? If by definition, it should be possible to do it much earlier, because we don't have any biological marker or medical test. And I think we will never have one that will do the work properly. Although we are looking for markers, we may find markers for subgroups, but we will never find a universal biological marker or whatever biological medical test that can for sure assist us for the whole group in making an early diagnosis. We have to be very clear about that. And so everything you find on the internet on EG or other things, it's rubbish. We are not able to do it at this stage. A second reason is that in primary health care, still professionals are not really familiar with autism characteristics, especially not in children with good cognitive or language abilities. This study which I referred to was a British study, also where physicians thought you could not diagnose autism before the age of 3. They were convinced that it was completely impossible. Autism is also often not the first prompt for referral to clinical services. At later ages, it is, but not in the very early age. Children are referred because they have motor problems or language problems, but not in the first place because they have autism. And there is a delayed referral for comprehensive diagnostic evaluation. People are not easily referred to a specialized center for a more comprehensive evaluation. Professionals sometimes say to parents, wait a little bit, it might grow out, and so on and so on. So that's another reason. We also, of course, have a very heterogeneous picture of autism. We have a variability of early characteristics. We have a variability of co-occurring difficulties. And there is overlap with other conditions, such as intellectual disability, language disorder, precursors to what later becomes ADHD, reactive attachment disorder, but also with typical development. For example, also young children in typical development show some repetitive behavior, for example, which is not very, very uncommon. We also should be careful about trusting too much instruments. The quality of screening and diagnostic instruments and procedures is not so high as we tend to think. And I'll come back to that during the talk later. And perhaps we also focus too much on social communicative science in early childhood. For example, this is a systematic review that we published a few years ago, where we looked at fairly early signs of autism, mainly in children at elevated likelihood, which could be followed up from birth onwards. Mainly siblings or with an already older brother or sister diagnosed with autism, and we could include 38 studies. And what we found is that the most promising signals were non-social, and the most promising early non-social signs of autism were difficulties with attention disengagement. When you show a stimulus on a computer screen, and you add a second stimulus at the side of the screen, children who later develop autism tend to have more difficulties with changing their attention from the central stimulus to the stimulus at the side. That's something that has been replicated several times also in our lab. And there is an atypical growth in fine motor development, and there is repetitive stereotype behavior more than what we see in peers that later do not develop autism. And this pattern already starts at 6 months, and we have the best discrimination from 12 months onwards. But these three signs, as said, are non-social. And we tend to look for joint attention, and we tend to look for communication and so on and so on. But maybe the very early signs of autism are of a non-social nature. Just to show you the variability as an illustration, this is from one of our cohorts where we follow up siblings. So we have siblings who later on appear to have a typical development, siblings who have an atypical development but not autism, then siblings who develop autism, and then children who are in a typical likelihood group. So it means there is no autism in the family. So we are able to follow these children from very early onwards, and when the diagnosis is then made, we can look back at how these children developed. But if you look at these groups, we looked at fine motor skills at 24 months and fine motor skills at 36 months. What you see is in the group that developed autism, we have children with very low fine motor skills, but we have also children with superior motor skills. And the same applies more or less 1 year later. This variability, especially here at 2 months, is less seen in the other groups. So there is a significant difference between the groups, but the most variability is in the autism group. And so we cannot say, look at children with motor problems. This is an additional thing. There are some children, and a substantial amount of children who have motor difficulties still at 2 years, but there are also children who perform very highly. And the group who performs very highly is also the largest group. The largest group who performs very highly is in the autism group. The same goes for language. This is where we compare. This is just an example. The receptive language of siblings with a typical likelihood, no autism in the family. So we follow them up from 10 months to 36 months. And what you see is this is a very predictable trajectory, and almost all children follow the same trajectory. When we look at the group of siblings with an elevated likelihood, at 3 years we made a diagnosis, and we had children with autism in yellow. We had children with what we call the broader autism phenotype, or you could say subclinical autism, if you want. Children with an atypical development in green, and children who appear to develop typically in blue. Now, what you see again is that the lowest performing and the highest performing children, they are children with autism spectrum disorder, while the other children are in between. So once again, it shows the heterogeneity. I could show you slides with the expressive language, with the general intellectual development, and so on and so on. And we would also always see the same picture, and that complicates also the early diagnosis. Now, should we avoid to diagnose early? Because maybe we are wrong, maybe it's not stable. Well, the literature tells us something different. In fact, for children diagnosed before the age of 3, in several studies, the stability ranges from 85 to 90%, which is very high, of course. Even Karen Pierce in San Diego, she already looked at children at 12, 13 months. There the stability was 50%, but it went up quickly. At 14 months, we already have a stability of 79%, at 16 months of 83%. In the elevated likelihood groups, once again, mainly in young infant siblings, stability between 18 and 36 months is 93%. Between 24 and 36 months is 82%. You may wonder why this is lower. This is because the children who already are detected at 18 months might have a clearer picture of autism, so it may be more reliable than the ones we were first detected at 24 months. And in another study by Brian and colleagues, stability between 3 and 9 years was almost 95%. So we shouldn't worry too much about the stability of the early autism diagnosis. The early diagnosis is fairly stable, although there are, of course, children without an early diagnosis who may still be diagnosed later on. But we should be more worried about false negatives than about false positives. So we should worry more about the children that we miss than about the children that we identify at an early age, or even already at a very early age. Now, why would we diagnose early? We don't do it because there is a competition to diagnose as early as possible. It's because there is increasing evidence that early intervention leads to better outcome. The evidence is not very, very extensive yet. We should not exaggerate it, but it's growing. It's growing, and the findings are confirmed. And we also have some evidence that the earlier we start, the better the outcome may be. In the study by Guthrie et al., they compared interventions starting at 18 months with interventions starting at 27 months, and the children who started at 18 months, they had a better outcome than the children who started almost 10 months later. Of course, it gives us a better understanding of the child. And we can use that in psychoeducation to inform the parents, to inform people in the larger family, professionals in daycare centers, and so on and so on. We can also offer support for the parents. Financial support, but of course also support how to deal with the child. For example, in my country, these young children get a lot of home-based interventions where professionals go to the home and to support the parents of these children with all kinds of challenges or difficulties they are confronted with. We can also adapt the environment to the child and make it more autism friendly. We can prevent or attenuate co-occurring or secondary difficulties because children are not able, for example, to communicate, and they get a temper outburst. These kind of things can be to some extent prevented. And on the whole, we believe that an early diagnosis may lead to better quality of life of the child and the family. Since autism is to a large extent also a genetic disorder, or a disorder with an important genetic component, it can also contribute and help the parents with further family planning. So there are quite some reasons why we would diagnose early, and we think that if we diagnose later, that we would miss important opportunities for early intervention when the brain has still a lot of plasticity. Now, there's always three aspects that lead to early intervention. First, there is the recognition of a potential need. Then we should go on to identify and diagnose autism, and then we can go move on to early intervention. And in this paper, people interested should read the paper because we cannot discuss all the factors, but they identified all the factors that influence the recognition, the identification and diagnosis in the early intervention, and the steps between them, and how people proceed. And then based on this, we can have a policy in a region or a country, but also professionals, like you understand most of you attending are, can also pay special attention to, for example, people with a lower socioeconomic status, parents who speak a different language in your case than Spanish, take into account religion and faith, and so on and so on and so on. So there are a lot of factors that impact who gets finally, eventually, access to early intervention. Now, to remind you, for some probably, maybe for others, it's good to explain this a bit. Early diagnosis takes two steps, and we always should make a clear distinction between screening and a comprehensive developmental evaluation. Some people think that screening is close to diagnosis, but this is not the case. Screening is the first step, and further steps will then lead to a diagnosis and to eventually intervention or further support. Autism screening of autism is a mental health screening. And in general, the main goal of mental health screening is to identify individuals with mental health problems who need intervention. And the goals of early mental health screening can be the identification of difficulties, the prevention, as I already said, and of problems, and the prevention of more problems. In autism, most often, to diagnose autism as early as possible and to start an early intervention where we target what we believe are pivotal social communicative skills, such as imitation, such as joint attention, for example, skills that we think are very important for further development. We always have to make a distinction between the level 1 screening and the screening of all individuals, regardless of their likelihood status. We can also call this the universal screening, and the level 2 screening targeted at individuals already identified as being at an increased level of likelihood. Because there is a family history of autism, because there is a specific medical condition. One of them could be preterm birth. I'll come back to preterm birth later. Concerns raised by parents or clinicians, or after the level 1 screening. And screening or the surveillance is often controversial, and as we said already in the title, there are always pitfalls and opportunities, always pros and cons. In this paper, published in 2014, to which we also contributed, and a lot of people also from Spain, like Ricardo Canal, as a senior author, we made an overview of the screening for autism spectrum disorder in Europe. And what we saw is that there were 18 different approaches. Level 1, level 2 screenings, questionnaires, observations, screening by parents, screening by professionals. What we also saw is that the focus was on early screening. And recently, this paper was published, not only for Europe, but worldwide. And it looked at screening, but screening only between 0 and 3. And in this paper, they identified 26 different screening tools and 75 profiles of adaptations of 26 screening tools. So we didn't learn from the previous European experience that we had too many screening procedures. No, we developed new screening procedures worldwide, only for the 0 to 3 group. But what the study also says is that most tools have significant limitations, and that's what we often forget. Now, the early autism screening, what are the pros? If we have an early stage detection, of course, we can diagnose earlier and we can organize early intervention as soon as possible. And then as soon as we have diagnosed, then we have all the benefits of the early diagnosis, which I mentioned a few minutes ago. Now, screening tests are not perfect, that we already said that, but on the other hand, they're easy to perform and they have a fair accuracy. And screening on a large scale reduces also social inequalities in the provision of care, because otherwise we see that people with a higher socioeconomic status find easier their way to diagnostic centers and so on and so on. If we screen on a large scale, yeah, we reduce this inequality to some extent. But there are also many challenges because, of course, screening does not detect all the cases, and we have a substantial number of false positives. And the question then is, do all these children have problems, and do they all require support or intervention? They cost a lot to society, because if you have a false positive, you have to do something with this child. So there is a further investigation, and then the result may be autism or not, but it costs a lot of money, money that is not always spent in the most efficient way, apparently. It also causes family stress, because we go to parents and we say to parents, okay, you have to fill out a questionnaire, and the questionnaire will tell us whether there is something wrong with your child. But most of the time, parents do not ask about this. Parents do not ask, can I fill out a questionnaire for autism? No, we go to parents, and then, so it causes stress. And what we also see is that, and we saw that in quite some studies, that there is a non-compliance of parents, that parents of young children say, okay, leave me alone. I'm not participating. Maybe I fill out a questionnaire, but if the result is positive, I do not participate in further steps. So that's something we have to take into account. And there are also quite some ethical issues, because if we screen, this can be a major and have a major impact on the life of a child, even if the screen is negative. Yet parents, to some extent, may be worried about their child, may take specific actions with their child, may be more careful, but also if there is a positive result, even if it's a false positive, and so on and so on. So we have to realize very well what we are doing with an early screening, and whether it is justified to do this. we should ask ourselves this question. I'll come back to that also later on. In major medical associations, national guidelines, and so on, have conflicting recommendations on early autism spectrum disorder screening. And in Europe, usually we do not have universal screening, but in the United States, there is a universal screening for autism. In some countries in Europe or in parts of countries, we also see that, but in most countries, we don't do a universal screening for autism. But if we do it, or would do it, when should we do it? Should we do it at 18 months, at 24 months, or should we do it earlier? And if we what do we do with children at elevated likelihoods? Should we screen them earlier than the general population? All questions that are not solved yet. Now, I will give some illustrations of the challenges, and I will spend most time on the validity of screening instruments and also a bit on a diagnostic instrument. I think most of you know these definitions, but so that we're all on the same page. Sensitivity has to do with the proportion of children with autism who score positive on the screener or on the diagnostic instrument. We call this the true positive rate. Now, in our field, a clinically acceptable rate is 70 to 80%. We prefer closer to 80, and of course, more than 80 is even better. The specificity is the proportion of children without autism who score negative on the screener, so the true negative rate. Again, we like to have a specificity of around 80% or higher. And this is what we usually know about screeners, and this is what is usually reported in the manuals and so on and so on. But there are all other definitions for us as clinicians that are even more important. Before that, a false positive is a child who scores positive on the screener but has no autism. A false negative is a child who scores negative on the screener but has autism, a child that we missed. And then there are two important values. The positive predictive value, which is the probability that someone who scores positive on the test has autism. And the negative predictive value is the probability that someone who scores negative on the screener has no autism. Now, both positive predictive value and negative predictive value depend on the prevalence. And we tend to forget this. By the way, there are no agreed upon standards for positive predictive value or negative predictive value. Now, to show what it means that it depends on the prevalence, I took this table from a paper by Lavigne et al. And what I put in, the line I put in yellow could be the autism line, because the prevalence of autism, more or less, is estimated worldwide around 1%. Now, if we take 1,000 children, so the examples are for 1,000 children, and we have a test, a screener with a sensitivity of 0.80 and a specificity of 0.80, then this seems good. This is what we expect, what we just said. This is what we expect in our field. But if we have 1,000 children, only 10 children will have autism, right? 1%. Now, if the sensitivity is 0.80, yeah, then we will pick up 8 of these 10 children. They are in cell A. They, according to the test, they have autism, and they also have autism in reality. So 8 children are in this group. But there are 189 children who test positively on the screener, but who have no autism. And the remaining 2 children with autism, they're not picked up by the test. So according to the test, the screener, they have no autism, but in reality, they do have autism. But there are also 792 children who have no autism according to the test and no autism in reality. But if we put this together for a disorder or a condition with a prevalence of 1%, like autism, then the positive predictive value is 4%, which means that if you score positive on a screener with good sensitivity and good specificity, in the general population, you have only 4% that the ones who score positive really have autism. On the other hand, we are 99% sure that the ones who score negative have no autism. To compare, if we would look like another condition such as ADHD with a prevalence of 5%, the numbers go up with the same sensitivity and specificity. It's not impressive, not at all, but it's again higher. We already have 17% chance that the child has ADHD. And if we would go for general all children with potential disorders and think this is about 30%, then the positive predictive value may be 0.63. But it's very important to remember this, that for autism in a general population, with a good screener, if a child scores positive, there is 4% chance that the child has autism. If you're interested, there is a calculator available for all prevalences or base rates and then to estimate these. So as mentioned in this paper, the positive predictive value, the paper is a clinician's guide to avoid misinterpreting the results of screening tests. Screening tests give when the disorder has a relatively low prevalence, it is near impossible for a screening test to have sufficient positive predictive value. How can we solve this? One solution could be to use a second screener after the positive screen. Now, this is not an example for autism. This is an example for the CBCL and the SDQ, which are 2 questionnaires used for general difficulties or problems in children. Now, here you see the psychometric qualities of the CBCL with a positive predictive value of 0.49, and this is the SDQ with a positive predictive value of 0.64. But if you would first take the CBCL and only then go further with the children who score positive on the CBCL and then take an SDQ, then your positive predictive value goes up to 0.86. So a second screener after a positive screen can heighten your positive predictive value. And so it could be an option that you say, okay, if we have twice a positive screen, then we can advise a full diagnostic assessment. If there is 1 positive and 1 negative screen, we should closely monitor this child, but perhaps wait a little bit before we take further steps. And of course, if there are 2, if there is a negative screen, we don't test the second time, but we know then that quite sure that this child has no autism. There's another indicator which is to some extent important. There are more, but it's a positive likelihood ratio, and it indicates how much the probability of having autism increases after a positive screen. And you also have the negative likelihood ratio, but we won't push it too far. Now we have also a general accuracy of the test, which is expressed as the AUC, the area under the curve, and there we would like to have an accuracy of again at least 80%, and if we have above 90, we speak of an excellent instrument. And in our field, which means the field of mental health, we don't have perfect screeners. This is a perfect screener, the C1. A is chance. You have 50% chance. You could also use a coin and throw it in the air and decide whether it's autism or not. But we usually have B instruments, which are between complete accuracy and the 50%. We don't have screeners of 100%. That doesn't exist in our field. Now, the problem is that often only sensitivity and specificity or the general accuracy are reported, but they are often overestimated, and they vary from study to study. But these are evaluations of the instrument, and the positive predictive value and negative predictive value are evaluations of individual people. Now, you as clinicians, you're not interested in the instrument, you're interested in the individual child before you. So for you, these are much more important to consider, because these are two different contexts, and one cannot rely on sensitivity and specificity to take decisions on individual people. So we have to look at the positive and the negative predictive value. But let me show you an example. It's a study we did some more than 10 years ago, where we screened 7,000 children in Belgian daycare centers. And we made a screening instrument here, which was called the checklist for early signs of developmental disorders, and we screened infants and toddlers between 0 and 36 months in these daycare centers, and they were screened by the daycare nurses, and so they were trained to use this instrument. Now, it looked good. We had a sensitivity of 0.80, we had a specificity of 0.94, we had an area under the curve of 0.90, we had a negative predictive value of 0.99, and we had a positive likelihood ratio of 12.89. These are excellent numbers, but I didn't give you one number, and that's the positive predictive value, because the positive predictive value was only 7%. So in these 7,000 children, we identified a lot of children for further evaluation, but only 7% of these children really had autism. And so we decided not to use the instrument in the field, because it identifies too many children for further assessment. So we also compared this instrument with parent reported instruments, and now we see that we have different accuracies, different sensitivity and specificity, and it also differs corresponding with the age, so 18 to 24 months or more than 24 months, we always see different numbers. So there is not one psychometric quality of an instrument. It depends on the age, it depends on the population, and so on and so on. So it's very difficult to have a complete view on what the screener really is telling us. Now, one of the most used instruments for early screening, also in your country, is the MCHAT. The MCHAT, there was a systematic review in 2018. Sensitivity 83%, specificity was lower, 51%. The positive predictive value for low risk, means for the general population, was 6%. The positive predictive value for children in the level 2 screening was 53%. We had a better prediction with follow-up by telephone, but it's also more time consuming and better at 30 months than at 24 months. But for the general population, only 6% positive predictive value. Now, this is the MCHAT. Other screeners do not perform better. I was asked to write a commentary on the article, and what I wrote is that we have promising screening instruments that can be used to identify children at an early age who may profit from promising early intervention, no more, no less. And the title of my comment was Promising, but more is needed. And that's also what we still think today. Now, you know that probably there is a modified, revised version of the MCHAT with the standard follow-up for screening. This was evaluated recently, but sensitivity and specificity are similar than 6 years ago. But still, the positive predictive value, even with the follow-up screening, which is actually a second step screening, was only for the low risk group around 50%, as you can see here for the general population. Interestingly, if you look at the positive predictive value for any developmental disorder, we go up to 89%. So although the MCHAT was developed for autism, the MCHAT seems to be quite good to identify developmental disorders in general, which also illustrates that there is quite some overlap, as I already told earlier. Okay. Now in Spain, I also participated in this study. The numbers are even lower than in the general overview, which I showed you. In this study with a follow-up of the MCHAT revised, the positive predictive value was 39%. Another thing that we should discuss is the preterm born children. Preterm born children, we did a study with very preterm or extremely preterm born children, born before 26 weeks, which is, of course, a very specific group. This group was followed up by us until the age of 12, and by 12, 28% of these extremely preterm born children had an official diagnosis of autism. 11% scored positive on ADI or ADAS, and another 22% scored positive on screeners, and only about 38% of the children had no indication of autism. And in a more recent study, we looked at children born before 30 weeks, and not 26. But also in this group, we found a prevalence of autism of nearly 13%, and almost 15% had the broader autism phenotype, the subclinical autism, if you want. But we looked, these children were again followed up from very, very early onwards in life. And then we looked at some autism screeners, and we looked at the SRS and the SEQ in these children. So we gave them a diagnosis, but we also independently took screenings instruments. And what we see is that they don't do very well. The sensitivity is very low, which is reflected in a low positive predictive value. So the SRS and the STQ have a very low positive predictive value, although in this group, the prevalence is already higher than in the general population, as we just have shown. But also the ADOS, the golden standard instrument that some people think equals a diagnosis, didn't do so well. Well, the ADOS in preterms had a sensitivity of 100%, and that's good, which means that we picked up all the children, but the specificity was only 77%, which was reflected in a positive predictive value of 38.9%. So while we picked up all the children with autism, we picked up far more children. And so if you scored positive on the ADOS 2, there was only about somewhat less than 40% chance that you really had autism. So we tested too many children with the ADOS, you could say, and we couldn't trust the ADOS to make a real diagnosis in this group. We also looked at the different results on the ADOS at 3 different ages. So at 18 months, 24 months, 36 months, we had this ADOSs from a subgroup of children at all these ages. And of course, there are children who always score negative on the ADOS and who don't have autism, but there was only one child who scored 3 times in a row positive on the ADOS. And then you saw all kinds of patterns. You saw children who didn't score at 18 months, but at 24 months, and you saw a child scoring at 18, another 24, and again at 36. And also the opposite, not yes, not again, and so on and so on. So don't trust the ADOS with preterm born children because it gives very, very weird results. We also should take into account the phenomena of regression. In this study recently published in the United States, it was confirmed that a substantial subgroup of children with autism have regression, and 26% in this group of more than 600 children that were evaluated. There were children with language-only regression, children with social-only regression, and children with language and social regression. We published a few years ago an overview of the literature, and we found similar figures. About or around 1/3 of the children, or somewhat less, somewhat more, show regression. And this regression, if there is no clear neurological reason, seems to be typical for autism, and it's very important also to look at for early diagnosis. But we did a study with 100 children, and what we discovered is that of these 100 children with autism, 24 showed regression before 36 months. But there were also 12 showing regression after 36 months. So if we would screen at 18 months, we would presumably not detect a substantial group of infants who develop autism. Not a part of this group, but certainly not these children. And we had 2 types of regression. I can't go into details, but the phenomenon of regression in itself is important and tells us much more about a potential autism diagnosis than the fact what the screener tells us at a certain age. Now, we are about to finish a very large study together with the University of Leuven, where we look at 3 groups of children who have an increased likelihood for autism, infant siblings, premature infants, and also infants with very early feeding problems. We follow these children from 5 months onwards, and at 36 months, we give a best estimate, a clinical diagnosis. And we do a very comprehensive evaluation of these children, where we look at genetics and metabolics, where we look at the brain with FNIRS and EEG. We look at facial dynamics. We take 3D pictures of the face, and we look at facial expressions. Of course, we look at all the behavior, or the temperament, motor skills, whatever, and also at the environment and the parent-child interaction. And the goal of this study is to develop a user-friendly and easy-to-use screening protocol, not based on one instrument such as the MCHAT or the EZAT or whatever, but on a few variables that we have easily available, and that can be used by primary health professionals. And then we would like to develop a more extensive likelihood assessment model for autism based on an optimal combination of genetic, metabolic, neurophysiological, and so on parameters that can be used by specialized diagnostic services. And so we would be able to predict the chance that the child will develop autism at 36 months, but we would be able to predict it at a younger age. And so even before the autism is fully emerged, this would give us the possibility for early intervention, even in the prodromal phase. We are now currently also testing prodromal intervention because I said this study is almost finished. So when we have our models, we should also be able to offer something to these children. And so we hope to optimize the quality of life of these children and their families. And we also have a socioeconomic and ethical component in the study. We did some first analysis, and it looks quite good. We do far better than the ADOS and the QChat, for example, which is a similar instrument as the MCHAT. But we also noticed that the best prediction models use data from 2 time points. As you know, we had 4 time points. The best models use data of 2 of these time points to predict the diagnosis. Hopefully, in a year or so, we will be able to fully inform you on this model. And so it offers the possibility to have a 2-stage multi-panel screening procedure, to have a likelihood assessment at a very early age, and then we can go on at a somewhat later age and do a full diagnostic evaluation. Now, we should also be careful if we install intervention at a very early age, that we realize very well what we are doing. And Jonathan Green recently published this paper, and he argued that we should see these early interventions as an early environmental adaptation to neurodiversity, producing positive outcomes. And it should not be clearly the goal to change or eradicate autism itself. And early preemptive intervention or prodromal intervention could be then the foundation of a systematic, evidence-based, efficient, an ethical approach to healthcare delivery in the condition. I conclude because we're almost 1 hour talking, and you might get bored or tired, but I think early screening and diagnosis of autism has many challenges, and I showed a few of them. The screening and diagnostic instruments are promising, but they are far from perfect, and so they can never be decisive on their own. We should realize that. Increasingly, I noticed that people rely a lot on screening instruments and on diagnostic instruments, but we have to perhaps give more credit to the clinical judgment and also to the concern, both the concern of parents and the concern of professionals. In this study of Sheldrick in the group of Alice Carter in the US, they published a few years ago this paper, and they say, okay, we have children who screen positive on an instrument, on a screener, on an early screener. That is this group, and we also have concern from professionals, and we have concern from the parents, and so you have several combinations. You have children with a positive screen and a double concern, and you have children with a negative screen and a concern, and so on. But there are three major parts. Path A are children with a positive screen and a concern, at least one. Path B are children with a negative screen and a concern, and path C are children with a positive screen and no concern. Now, I can't go into detail, but what happened is they looked at who goes further for level 1 and level 2 screening and diagnostic evaluation, and how much time do we spend, and so on. Of the 311 children who had a positive screen and concern, they eventually diagnosed 156 children with autism, and they spent around $967 per diagnosis. For the children who had a negative screen, but where there was at least one concern, from 121 children, 33 were diagnosed, and they spent around $1,235 per diagnosis. Now, the children with a positive screen and no concern, 183, only 8 were diagnosed eventually, and it costed $1,705 per diagnosis. Now, of course, this is a very economic way of looking at it also, but it also tells us that we should not only look at the screening, we should also take into account the concern of parents and professionals, and the concern of professionals obviously has to do with their clinical judgment skills. They seem to be more important and more efficient than the screening instrument itself. So we also show that autism screeners can tell us more about who screens negative than about who screens positive. If you screen negative, the chance is high that you don't have autism. If you screen positive, well, the chance is very low that you have autism. You may have autism, but the chance is very low, and we cannot work with that in clinical practice in an economic way. So if we have a positive screen, we need a second step before deciding to start diagnostic assessment, a second screener, an observation, whatever. In the future, we are also working on that. It could also be a device that more objectively tells you something. I'm not allowed to tell this because we signed a contract, but we are working on devices that can reliably tell us something about stereotype behaviors in very young children, such as two walking and turning around. even without that an adult has to be present to make the observation. So this kind of tools will also be important to add to the positive screen of an instrument like the MChat. Of course, screening only makes sense if we can offer a comprehensive diagnostic assessment, and if early diagnosis leads to support or intervention and a better quality of life. And we saw in one of the slides in the beginning that a lot of factors have an impact on this process. So we have the responsibility to facilitate the step to screening, to diagnosis, to early intervention. But in any case, there is a need to further improve screening methods. And I think we can only improve this, as said, with multi-stage and or multi-panel approaches, as we are trying to do with the Tiara study, which I briefly talked about. We should not maybe focus too much on one time point or one screening at a certain age, 18 months, 24 months, whatever, but more on atypical trajectories and mechanisms in the future. Now, the insights we have from very early autism research can help us to further develop interventions. And as we learned from our review of the non-social science, maybe at a very early age, we should train other things than social communication. We should probably train attention skills or focus on motor skills or whatever. Research will further tell us. So even in the prodromal phase, when there is not the complete picture of autism yet, we probably should focus on other skills and other abilities that we want to train. We should also never forget that we are dealing with individual children with individual trajectories and individual needs. And one size fits all does not exist in the heterogeneous group of individuals with autism. And we should also ask us always some ethical questions. If we want to implement the research findings in daily practice, as already said, should we screen every child? And what is the aim of early intervention? What do we want that early intervention changes? What do we mean by a good outcome? Is it improving the language if there is no language? Is it improving the parent-child interaction? As said, it is not trying to let disappear the autism in itself. And what does a better quality of life mean for the child and for the family? And is that the same for the child and for the family, and so on and so on? So I think it's also important that we always consult with relevant stakeholders, with people with autism, but also with parents and other stakeholders. That's what I wanted to tell, and I guess it's more or less an hour that we spent. So
Pues muchísimas gracias, Herbert, por tus interesantes aportaciones que desde luego que van a contribuir a que, pues bueno, en este curso aprendamos todos, las personas que han acudido hoy al webinario y las que lo puedan ver a posteriori, a mejorar los mecanismos de detección y de diagnóstico en torno al autismo, conocer cuál es la realidad, ¿no?, de las investigaciones y lo que realmente se puede conseguir desde esa perspectiva tan ecléctica y tan práctica. Creo que nos ayuda a todos. Y bueno, pues agradecer una vez más esta contribución. Muchas gracias a Lupe también por la asistencia, a Sergio por la excelente interpretación, como nos tienes acostumbrados, y bueno, a todas las personas de diferentes latitudes que nos han acompañado en esta tarde. Muchísimas gracias.
okay. Thank you.
Gracias.